I'm going to explain how to do this question, which is from exercise 24.3, question 3. And in the process of explaining this, we're going to discover the addition rule for probability, which is a very useful rule. So the question says, there's 20 students who walked into a classroom. Of these, 13 were wearing headphones and 15 were typing messages on their phones. 4 students were not wearing headphones nor typing messages on their phones. Draw a Venn diagram to show this information, part A. Part B, what's the probability that a student was wearing both headphones and typing on their phone when they walked into class? Okay, so let's draw a Venn diagram. We need our rectangle, our universal set. We need 2 circles, one for headphones and one for people who are messaging. So let's call it H and let's call it M. I always told you that when you do a Venn diagram, you have to start in the middle. You have to start with H and M, but we don't have the number of people who are in the middle there. What we do have is that there are a total of 20 people. And so that 20 is going to be in this area. We also know that there's a total of 13 people who wear headphones. Well, that means this 13 is going to be in this circle, but it's not one area. There are 2 areas that make up that circle. So that 13 is broken over 2 different places. So we can't put it in to the diagram. And we're also told that the people who are messaging is 15. And so that would be in this circle, but we can't put that in because that 15 covers 2 areas as well. Right, the final bit of information we're told is that there are 4 people who aren't wearing headphones and they aren't messaging. They're doing neither of those things. And that area is this one here, which goes around the circles. And so we can put that in. We can put a 4 there because that's a single area. And we know, well, that's definitely 4. Well, now that we've done that and we've put a 4 there, we now know something else. It's not obvious how helpful it is at this point, but it is extremely helpful. We know the number that are in H union M or H or M. We know the number in H or M, which is in both circles, is equal to 16, which is the 20 minus the 4. All right, so that area we know. Can we use this to help us solve the problem? Well, yes, we can. Because we now can deduce this. The number in H or M is equal to the number in H, plus the number in M. But if we do that, we've counted that middle section twice. We counted it once when we used the number in H, and we've counted it again when we've used the number in M. So we should subtract it because it's in there twice. So the number in H or M is equal to the number in H plus the number in M minus the number in H and M. Now that's the addition rule for probability. You should put that in your memory somehow, or just think about a Venn diagram and how you can create that rule, because we know everything bar the intersection. We know everything bar the number in H and M. We know that the number who are in the headphone circle is 13. We know the number who are messaging is 15. And so we can put those details into the equation here, and we'll have the number in H or M, which is 16, is equal to 13 plus 15 minus the number in H and M. And that's what we're trying to find out. What is that middle section? Of course, we want to put that in first. Well, that's a pretty simple equation to solve, and we'll find the number in H and M is 12. Because that's the intersection, we can just put that straight into that one little area there, a 12. And from there, we know that the number of headphones was 13, so there must be a 1 in the other area. The number who are messaging is 15, so there must be a 3 in the other area, and we have filled out our Venn diagram, which answered part A. Incidentally, we also answered part B by finding out the number in the intersection, or the number of students who are wearing headphones and are messaging as they enter a classroom. I know that none of you would be doing that as you enter our classroom. Bye.